The Sonoran Desert doesn't look like a place where cities should exist. It's dry for most of the year, brutally hot in the summer, and unpredictable when rain finally does come. Water is scarce, and when it does flow, it doesn't stick around for long. Rivers swell and shrink, sometimes disappearing into the ground or shifting their course entirely. And yet, more than 1,000 years ago, this harsh landscape supported a thriving civilization. Not just small settlements either, but organized communities with agriculture, trade, and infrastructure that still raises questions today. At the center of it all was water. Not just finding it, but controlling it. The Hohokam people didn't simply adapt to the desert. They reshaped it. They built an irrigation system so extensive that it stretched for hundreds of miles, connecting rivers to fields across vast distances. Some of these canals ran for more than 15 miles, carrying water across uneven terrain that would challenge even modern planners. And they did all of this without metal tools. No steel blades, no machinery, no written engineering manuals. Just stone, wood, and generations of observation. That's where things start to get interesting. Because at first glance, the canal system doesn't make much sense. When early engineers and archaeologists began studying the remains in the early 20th century, they expected to find something predictable. Straight channels, consistent slopes, clean, uniform construction. Instead, they found something that looked irregular. Some canals were shallow, barely more than a foot deep. Others were much deeper, carved into tougher ground. Certain sections curved in ways that didn't match what textbooks would recommend. The gradients changed along the way, sometimes flattening out, sometimes steepening unexpectedly. On paper, it looked inefficient, but in reality, it worked, and not just barely. It worked well enough to support large agricultural communities in one of the most unforgiving environments in North America. That disconnect between expectation and reality is what kept researchers digging deeper. Because the question wasn't whether the canals worked. The archaeological evidence made that clear. Fields were irrigated, crops were grown, populations were sustained. The real question was how. To understand that, it helps to look at the rivers the Hohokam depended on. The Salt River and the Gila River were the primary sources of water. These weren't calm, predictable rivers. Their flow changed with the seasons. Sometimes they carried strong currents after rainfall. Other times, they slowed down significantly or broke into smaller channels. Building a canal system from rivers like that isn't just about digging a trench and letting water flow. The slope has to be just right. Too steep and the water moves too fast, eroding the canal walls. Too flat and the water slows down, sinks into the soil, or stagnates. Modern irrigation systems rely heavily on precise calculations to get this balance right. The Hohokam didn't have equations written down, but they had something else: time. Generations of it. Instead of forcing the land into a rigid design, the Hohokam learned to read it. They paid attention to how water behaved after rainfall. They noticed where it pooled, where it flowed smoothly, and where it disappeared. Over time, patterns emerged, and those patterns became the foundation of their engineering. Rather than keeping a constant slope, they adjusted it along the canal's path. In areas where the terrain dipped or where water needed to move quickly, the slope increased slightly. That helped maintain flow and prevent sediment from settling. In flatter areas, the slope decreased. That allowed water to spread out into smaller channels that fed agricultural fields. To someone expecting uniformity, this might look inconsistent, but it was anything but random. It was responsive. That's what made the system work. The canals weren't designed in isolation. They were designed as part of a living landscape, constantly interacting with soil, water, and terrain. Soil in particular played a huge role. Different types of soil absorb water differently. Some hold moisture well, while others let it seep through quickly. The Hohokam took advantage of this. In areas where seepage was a risk, canals were adjusted in depth or reinforced with available materials like clay and rock. In other areas, slight seepage may have actually helped, slowly watering nearby ground instead of wasting water entirely. It wasn't about perfection, it was about balance. And that balance extended beyond individual canals. The Hohokam didn't rely on a single massive channel to do all the work. Instead, they built networks. Multiple canals ran alongside each other or branched off in different directions. If one section needed repair or became blocked, Others could continue delivering water. That kind of redundancy isn't just practical. It's resilient. It means the system doesn't collapse when one part fails. And in a desert environment, that kind of reliability can make the difference between survival and collapse. As the canal networks expanded, so did the communities they supported. Fields of crops began to spread across the desert. Corn, beans, and squash formed the foundation of agriculture. These crops were well suited to the environment and complemented each other when grown together. But the Hohokam didn't stop there. They also cultivated cotton, which suggests a level of specialization beyond simple subsistence farming. Cotton requires care, planning, and consistent water supply. That tells something important about the canal system. It wasn't just functional, it was dependable. Dependable enough to support not only food production, but also materials used for trade and craftsmanship. And with reliable food production came population growth. Settlements became more organized. Structures appeared that went beyond basic shelter. There were designated areas for storage, for crafting tools and goods, and even for communal activities. One of the most well-known sites, often referred to as Snaketown, shows just how developed these communities became. This wasn't a temporary camp. It was a structured settlement with planning behind it. And that planning traces back to water, because without a stable water supply, none of it would have been possible. The canals made the desert livable, but building them wasn't a one-time effort. They required maintenance, constant attention. Sediment had to be cleared. Walls needed reinforcement. Channels had to be adjusted as conditions changed. This suggests something else about Hohokam society: coordination, large-scale cooperation. A canal system stretching hundreds of miles doesn't maintain itself. It requires organized labor, shared knowledge, and some form of leadership or collective decision-making. And yet all of this existed without written records detailing how it was done. No blueprints have been found. No manuals explaining the system. The knowledge lived in practice. It was passed down through generations, likely through teaching, observation, and direct involvement. Young members of the community would have learned by working alongside experienced builders and farmers. Over time, they would understand not just what to do, but why it worked. That kind of knowledge is different from written instructions. It's flexible, it evolves. And in an environment as unpredictable as the desert, that flexibility is an advantage. Because conditions change, rivers shift, weather patterns fluctuate. A rigid system might fail under those pressures, but a system built on observation and adaptation can adjust. And that's exactly what the Hohokam system did. Even the scale of construction raises questions. Some of the larger canals were several feet deep and wide enough to carry significant volumes of water. Digging something like that without metal tools isn't quick or easy. It requires effort. A lot of it. Stone tools can cut and shape, but they're slower and wear down faster than metal. Wooden tools can move soil, but they're not ideal for harder ground. So how did they manage it? The answer isn't speed, it's persistence. Work would have been done over long periods, with many people contributing. Instead of rushing to complete massive sections all at once, construction likely progressed gradually, expanding and refining the network over time. Each generation building on what came before, improving it, adjusting it, extending it further. That gradual growth is part of what makes the system so effective. It wasn't designed all at once, it evolved. And because it evolved, it fit the land better than a rigid, pre-planned system ever could. By the time the canal network reached its full extent, it had become one of the most sophisticated irrigation systems in the ancient Americas. And yet, for all its success, it wasn't permanent. Sometime around the 1400s, the system began to decline. The reasons aren't completely clear. Environmental factors likely played a role. Extended droughts could have reduced river flow, making irrigation more difficult. Over time, repeated irrigation can also lead to soil changes, including increased salinity, which affects crop yields. Social factors may have contributed as well. Large systems require cooperation, and any disruption to that cooperation can weaken the entire network. What's clear is that the canals were eventually abandoned, but they didn't disappear. When later settlers arrived in the region centuries later, they found traces of these ancient waterways still visible in the landscape. Some were even reused. In fact, parts of modern canal systems in Arizona follow routes established by the Hohokam long ago. Different tools, different technology, but the same underlying logic. That says something about how well the original system worked. Because even after centuries, its design still holds up, and modern analysis has only reinforced that. With better tools to measure slope, flow, and efficiency, researchers have been able to study these canals in more detail. What once looked irregular now looks intentional. The variations in slope, the changes in depth, the placement across the terrain, all of it contributes to a system that manages water effectively under challenging conditions, not by ignoring physical principles, but by working with them in a way that isn't always obvious at first glance. That's part of what makes this story so compelling. It challenges assumptions about what engineering is supposed to look like. It doesn't always follow straight lines or perfect symmetry. Sometimes it looks uneven, adaptive, even messy. But that doesn't mean it's flawed. In this case, it means it's optimized for a very specific environment. And that environment demanded creativity, because in the desert, there isn't much room for error. Water is too valuable. Every drop matters. And the Hohokam found a way to make those drops count. That idea of making every drop count didn't just shape how the canals were built, it shaped how the entire system functioned day after day. Water didn't simply flow from a river into a single field and stop there. It moved through a layered network, shifting from large main canals into smaller distribution channels, then into even narrower pathways that fed individual plots of land. Each step required control, timing, and awareness of how much water was moving and where it needed to go next. This wasn't random flow, it was managed. And that management likely depended on shared routines within the community. Water would have been directed based on need, possibly rotating between fields to ensure that no area was overwatered while another went dry. Even without written schedules, patterns would have developed over time, refined through experience and passed down across generations. That's where the real sophistication shows up, not just in construction, but in operation. Because building canals is one challenge. Keeping them working efficiently over years, decades, even centuries is another. Sediment buildup alone could disrupt flow if left unchecked. Rivers naturally carry silt, especially after seasonal floods. When that silt enters a canal, it doesn't just disappear. It settles, slowly raising the canal bed and reducing the amount of water that can pass through. So maintenance wasn't optional. It was constant. Sections would need to be cleared, reshaped, and sometimes rebuilt. Edges reinforced. Flow redirected when conditions changed. And since the desert environment doesn't stay consistent, the canals had to respond to those changes. Floods could damage sections. Dry periods could expose weaknesses. Over time, adjustments would have been made again and again, each one improving the system's ability to handle the next challenge. This cycle of use, observation, and adjustment is what kept the system functional for so long. And it also explains why the design appears irregular when viewed all at once. Because it wasn't built in a single moment. It was built in layers, each modification reflecting a specific need at a specific time. That's very different from how modern systems are typically designed. Today, engineers often begin with a complete plan, calculate everything in advance, and then build according to that blueprint. The Hohokam approach moved in the opposite direction. Start small, observe what happens, adjust, expand, repeat. Over time, that process created something that looks complex, but is actually the result of countless small decisions made carefully and deliberately. And those decisions weren't isolated to engineering alone. They influenced how people lived. Agriculture, for example, wasn't just about planting crops and waiting for them to grow. It was tied directly to water availability. Knowing when water would arrive, how much would be available, and how long it would last would have shaped planting schedules, crop selection, and harvest timing. That level of coordination suggests a deep understanding of both the environment and the system they had built within it. It also suggests trust, because when water is shared, cooperation becomes essential. If one group takes more than needed, others suffer. If maintenance is neglected in one section, the effects can ripple outward, so the success of the entire system depended on collective responsibility. That's not something tools alone can create. It comes from social structure, from shared knowledge, from a sense that the system belongs to everyone relying on it. And that might be one of the most overlooked parts of the story. The canals weren't just physical structures, they were part of a larger system that included people, habits, and relationships. Take that away, and the canals alone wouldn't be enough. That becomes especially important when looking at why the system eventually declined. Environmental pressure is one possibility. Extended droughts would reduce river flow, making it harder to supply water across long distances. Even a well-designed canal system can't deliver water that isn't there. Soil conditions may have played a role too. Over long periods of irrigation, especially in arid environments, salts can accumulate in the soil. This process, known as salinization, can make it harder for crops to grow. Yields drop, fields become less productive, and when productivity drops, the entire system feels the impact. There's also the possibility of social strain. Large systems require coordination. If that coordination weakens, even a well-built network can start to fail. Maintenance might lapse, distribution might become uneven. Small problems, left unresolved, can grow into larger ones. What's important is that there's no single confirmed cause. It likely wasn't just one factor. More likely, it was a combination. Environmental stress, soil changes, and shifts in social organization could all have contributed, gradually reducing the system's effectiveness until it was no longer sustainable. And when that happened, the communities that depended on it had to adapt again. This time, by moving on. By the time later groups entered the region, the large canal networks were no longer in use as they once had been. But they hadn't vanished. The land still held their imprint. Channels carved into the earth. Subtle changes in elevation. Pathways that once carried water across miles of desert. And those pathways didn't go unnoticed. When settlers began developing the region centuries later, they encountered these ancient canals and recognized their value. Some were cleared and reused. Others influenced the layout of newer systems. In a way, the Hohokam design continued to shape water management long after the original builders were gone. That kind of longevity says a lot, because it means the system wasn't just effective for its time, it was fundamentally sound. Modern analysis has only added to that understanding. Modern technology has allowed researchers to take a second look at these ancient canals with far greater precision. Tools that measure tiny elevation changes and simulate water flow have revealed something unexpected. What once appeared irregular or inefficient now shows clear patterns. Slopes shift in response to the terrain, depths change based on soil behavior, and curves follow the natural shape of the land rather than resisting it. Instead of forcing water into straight, rigid paths, the system works with the environment, guiding flow in a way that reduces energy loss and improves efficiency. This approach reflects a deeper principle. Advanced engineering is not always about complexity or high-end tools. Sometimes it's about understanding the environment well enough to work alongside it. The Hohokam achieved this without metal tools, written formulas, or modern instruments. Their knowledge came from observation, experience, and continuous adjustment. Over generations, they refined a system that could sustain entire communities in a harsh desert. This challenges the idea that innovation depends only on technology. Their methods show that patience, adaptability, and close attention to nature can produce results that remain relevant even today, especially in regions still facing water scarcity. Still teaching, and that's what makes the Hohokam Canal system more than just an ancient achievement. It's a reminder that innovation doesn't depend only on tools. It depends on how those tools are used, on how closely people are willing to observe, adapt, and learn, and on how well a system fits the world it exists in. Because when it does, it can last far longer than expected, sometimes even long enough to influence the future. If this deep dive into ancient engineering and human ingenuity was worth the watch, consider hitting the like button and subscribing for more stories that break down how people solved complex problems long before modern technology existed. There's always more to uncover, and the next story might be even more surprising.